Thanks for having me. I'm one of those speakers that is from one of those 4 countries. I'm originally from Germany. This is a small German town. Small towns, whether in Germany or other places, tend to have small roads that lead into them. Right? You would not be surprised for this road to lead to maybe this town. The biggest German city is Berlin. It's not that big, 3.5 million people, I think, is what it is. But when you have a bigger city, you would be surprised to find that little road going into that city. In fact, when you have a bigger city, a bigger structure, you create more infrastructure to support it. This is, by US standards, not a particularly huge highway, but it's bigger than one for a small town. And you need it to support the complexity of the bigger entity. It can get huge, right? This is a highway interchange in China, feeding a couple highways around a small Chinese city of 8 million people or so. And so it can get very, very big. And similarly, when you're working on these kinds of structures, there's a similar thing that happens. If you're in a town, you're going to have a small site of construction and a little bit of annoyance for a few folks. And if you're working on something bigger, it's probably going to annoy a lot more folks. It's going to take a lot longer. I just heard this morning, though, not in Birmingham. I-20 is way faster than everyone thinks, and it's cheaper and whatnot. So you all have this figured out. Generally, where I'm from, we don't have this figured out. What I'm trying to say is the infrastructure that you have will support adequately your thing only if it's in the correct size. And both to get a take for what the room's like, as well as to get you properly woken up this morning, let's do a bit of audience participation. Stand up if you, all right, there's a couple bullets now. So you just stand up whenever you see yourself reflected or one of your projects reflected here. So you have a code base that has more than 50 models. Okay, there we go. It's not everyone yet, I think. If you have a class in there with more than 1,000 lines of code, I don't know why I'm starting to yell when you stand, but I feel like that's appropriate. Okay, a couple more folks stood up. You have an active record model with more than 30 has-manys. Okay. You can't run your whole test suite on your machine. Or you can't run your test suite in under 20 minutes on your machine. Okay, so look around you. There's a bunch of you. Hi. Good morning, all of you. And everyone else is free to stand up as well if you need the stretch. But thank you so much for participating. So I would argue in the analogy of town and city, you're probably building a bigger thing that is more akin to a city than you are a tiny thing that is more akin to a town. I'm calling this talk Structural Engineering in Ruby. And this slide is purple for 2 reasons, or pink or whatever this is. One, because I've been in the past accused of burying the lead and not kind of starting with the most important point. And 2, because when Brian and I talked about me coming out and speaking, he said, well, I had done a workshop with Proctor U, and that's how we started to talk. And he said, well, you could just come and talk about components and component architectures or anything else that can help. And I took that very seriously, that second part, and I was like, well, what else is there that does that? And so I thought about that for a while, and so I'm going to make a bold statement, and I hope that through the rest of the day you'll convince me that I'm wrong. The only thing that can ultimately help you rein in the complexity in your application are components. Okay, the caveat here is that says, I read it a bit wrong, but it says within one app. Right, we'll hear later from Julia about how we want apps to communicate, and that's a very important topic as well. But the building block of that's always applications. And so within an application, right, bold statement coming your way, the only thing you can do are using components. More bold statements. As a language, Ruby does not have components. However, gems can act as components, and they work very well. For Rails, it's not so ideal, and we'll get into why, but it also works. And I want to make things better. So I have 3 parts to this talk this morning. One, I'll give a kind of complete overview of how I tend to structure applications using components. So just a quick run through of how that looks. Second, I'll talk about why I made that last statement about why kind of it doesn't feel right or feel quite as good with Rails. And then third, I want to call you to action and get you to help me make things better. So this is based on a book I published a couple years ago, Component-Based Rails. And so after this talk, you don't need to read it, right? Because I'm giving you the short version. So let's go over a very small application that is in a component structure. So first thing I want to point out, it is not a cutoff list here that at the top of this thing there is no app folder. This app does not have one. So if there's no app folder, where's our functionality? Well, we can have functionality. We pull in all sorts of functionality all the time via our dependencies. So let's look at the gem file, or rather a part of it. And in this particular gem file, you'll find this one construct, this path components, which loads a couple of gems. And this tells Bundler to look locally into the folder structure to find these dependencies. And if we do go over there and look at there, we find those gems that we just listed as well as some others. Let's do a double take, right? Okay, so there are some dependencies, some stuff going on here. Let's look at the routes file to see if the app actually delivers something, and fair enough, it does, right? You may notice those are exactly the same gems that were in the gem file that are being mounted here. So the functionality of this application comes exclusively from the components. I'm going to use components, gem, and engine a lot and interchangeably, and probably wrong. Apologies for that. But it comes through these vehicles and not through the main Rails application. So to dive into 3 of those components, or I will dive into 3 of those components to kind of explain some of the things you might see. So let's look at games first. So, well, first thing I like to do when I look at a gem is to look at the gem spec, because it gives me an idea of what's going on. And first thing you might notice, or that I definitely notice, is we depend on Rails, not all of Rails, in this case just active record. And I realize, okay, you have another monitor in the back, perfect. So for those in the back that I'm noticing the font size is a bit small towards the end of the room, you have another screen over on your left. So we're depending on some parts of Rails, right? But we're also depending on this other gem here called Teams. And for those that paid close attention to when the list of other gems flew by, that's one of those local gems that wasn't yet referenced. But so if that's the case, then let's open the gem file. And indeed, there is this path construct again, this time with like ... because we're actually referencing the same components folder that we were already in with this gem. So this gem is depending on other gems inside of this same application. I hope you can start seeing that there are these dependencies that span the complexity of this application. Okay, let's keep going. So what's the entry point for a gem for Ruby? It's I don't know an actual name for this thing, but it's the file of the gem's name in the lib folder, right? So if we look into that file, not much going on. We just load one other file, namely an engine for this games gem. And when we open that engine, we see another couple interesting things. So one, we are in fact using a Rails engine to make this particular component work. We have this isolate namespace statement here, which makes all the Rails tooling expect and create everything inside of this namespace games, which will make sure that our gem can kind of act independently of other stuff and not collide with functionality that comes from other parts of the app. And then this one was one of the things we needed to find out, one of the pitfalls when we were starting to build out applications with this technique, and that is, this is a little hack that makes sure that migrations that are in this gem get automatically used by any gem that includes this particular component. So, when we then look at the rest, so there's migrations in here, but nothing special going on. We have the actual code. There's this game model that's being defined and some tests for it. But remember, we're still in this engine, so we're inside of a part of the app that is standing on its own to a certain extent. I mentioned the tests. I just want to point out this test script here at the bottom. You can see it's just a shell script that does everything you need to do to run the tests for this particular engine. That's because some engines need different things to be tested and or need to be set up differently. So by creating this little script, we can kind of make them all uniform. Lastly, we noticed there was no Rails dependency, only active record, so maybe not a surprise. No routes here. So let's look at another component where we will see that change. So when we look at games admin, which was one of the gems that was listed in the original gem file of the application, the gem spec here does in fact depend on Rails, right, and a bunch of other things. Whoops. So we do depend, again, on some of those gems that sit within the application. And we notice we have controllers and views, and if we do check the routes this time, well, sure enough, there is a resource here for managing games. And in fact, what's behind this in this case, because it's a sample application, it's just a scaffolded, all the things to administrate games. And if you do recall, we looked at the root routes file. That's referencing this particular route file and mounting the routes from this engine at that place. Let's look at one last of these. This one is called predictor. And same thing again. Notice here we have no dependency on anything Rails. We do have this dependency on TrueSkill. That's not a local dependency. That's a gem that can calculate the relative strength of competitors in games. But you could see no other dependencies. So we're just dealing with a plain old gem. And so looking at the file of the gem's name in lib again, we see it looks like a normal gem. We're loading this external dependency. We're loading some internal dependencies, right? And when we look at that, again, it doesn't matter what's going on, but here we're loading this prediction file. So it's loading these files to service them up to the rest of the application. Once again, there are tests that are local to this gem. And in this case, the test script, the bash script, is simpler because there's hardly any setup to do. In fact, we just need to bundle, and then we can run tests for this component. That's very soothing music. And finally, just to kind of pull put a point on those test scripts. There's one file here in the root which is called build in this case, and well, effectively what it does is it finds all the test files wherever they may be, runs them all, and only if all of them pass, it'll give us a green build, and otherwise it'll give us a red build. So we've split out our test suite into these various components, but with this we're kind of pulling them back together so we can still report on the status of the application. The point is, it's just Rails, right, with a little bit of structure. And structure that is, I think, different, and I'll try to explain in the next part why I think it's different, and gives us a tool or tools that we can utilize to build bigger applications better. One of the things you can do when you have this structure is show it, right? I was commenting on the couple of blobs here in red, and we saw these arrows are the dependencies that we saw in the gem files, right? And the names are obviously the names of the gems. So that's almost everything in this app, but the box around it all, that's the application, right, which depends on some of these gems directly and then on others of them indirectly via their subsequent dependencies. So we saw an additional layer of structure in the application. So let's look at structure, their costs, and and their benefits. Now it's good that this code is a bit small because I don't want you to read it. I want to talk about ways we structure it. So super common, we don't think about it. Well, methods, well, Sandy wants us to think about methods a lot more, and it's good that we do, but like I'm just saying, we use them all day, every day, that we don't, that I want to, well, maybe we do think about the benefits, but I do want to come up with an idea for cost as well this morning. So why do we use methods? And I'm going to be super kind of naive or not very sophisticated about this. They allow for reuse, right? If we have a method, we can call it from multiple places, and we don't need to state that code that is in the method multiple times. They also hide logic, right? We can put into those methods whatever, and then it just looks like the fun little method name, and that's all we need to know when we consume the method. Maybe it's not all we need to know because we're writing tests against this thing, and we're hoping to for the method to do the right thing. So we do care a little bit about what's in there, at least sometimes. So what are the method costs? I was pondering this a little bit, and A, to make my point, but B, to kind of like, because I couldn't come up with something better, let's just count how many lines of code we need to use to create a method. Well, it's 2. You have the line that defines the method and then an end. So I know the second line is pretty boring, and you might say, well, that doesn't count. But point is, it's very cheap to create a method in terms of the code that we write. Let's look at another construct that we use every day, and that's class. What do we do with classes? Well, it's similar to method in that it can bundle logic, but it does it kind of through bundling methods. But it also adds data through the objects that we can create based on those classes. And they allow for reuse. Same thing here. How much does it cost to create a class? Well, again, it's 2. You write the class name, and then you have an end somewhere below. Again, it's so cheap we don't think about it. Another one present in this file, namespace or modules. What are the benefits of modules? Well, one of the things I already came to, with Ruby we have the global namespace. So it's when we want to use external code from gems, I would think one of the reasons why originally modules were put in was you couldn't distribute code. It would just name clash all over the place if you didn't have a way to separate out various parts of code into names that were isolated, right? Or at least where you could have the hope of it being isolated. But we're dealing with a global namespace, and in that, modules help us prevent naming collisions. They also can be used to kind of group classes and methods, right, to indicate that they belong together. That's just an indication, right? We know you could just like have a module and then use code from all over the place, right? Or have its code be used from all over the place, right? There's no sort of strict delineation, but we could give an indication that things belong together. And what's the cost? At this point, you're like, well, this is boring, because it's once again the same. It's the same. We just have to that one line to define the module, and then somewhere it ends. The cost is again 2. So I was saying that the only thing that helps you ultimately manage complexity in an application is a component. And so what's the benefit of a component? Well, I already gave it away. I didn't want to bury the lead, but I do need to do it a bit more formally, and for that I want to do a quick segue and actually say what do I mean when I say component? Because I know I actually picked a bad name because React components, there's components in every language and they're slightly different. So let me go over the definition that I use for this, and then we'll look at, I already said gems and engines act as components, and we'll look at why those things, why those statements are true. So the way I use the word components is there are 2 things. They are labeled and unique content, and they have explicit, directed, and acyclic dependencies. So let's give it a try on the first thing. Labeled content. So obviously there's like things here that contain content, and there's labels. Is it unique? Well, I will challenge you tonight, maybe to bring your own beer. We'll buy 2 beers, and you'll try to tell them apart. It's a similar problem to this one here. Can you really tell the content apart? So maybe not perfect for this unique part of the content. Labeled for sure, unique maybe not. We want them to be more different. Let's try again. Supermarket, lots of labeled content. And yeah, like you can see there's like hygiene products and cleaning products and food items, and that's more like it, right? A labeled content that's really different and does something different. But there's also examples here, like there's probably 20 versions of mustard, and the only thing we can tell apart is like yellow and Dijon or something. And so you have a similar problem of like, well, actually there's a lot of labels that are the same. The best I could come up with was this guy's garage. A bunch of boxes, and look, the boxes look the same. It's kind of like the gems all have the same structure, but they are all labeled and have different names. Or so I thought when I first used this picture. So he has a bunch of good labels here and a bunch of good content. He also has a box up here and some down there that don't have a name on the label. So, shoot. And then he has 5 boxes of decor. And so when a number of years ago, my wife and I, we bought a house, you get a ton of stuff for like applying all these manuals and stuff, and you're so overwhelmed in the whole process that you're like not sure, should I keep it or not? And so you have this, I had this pile, and I was like, oh, this is great. I'm going to use folders and binders to just put these all in, and that way they're like organized, right? Dare I say structured, and I can just, like, I don't have to worry about them. So when you have 5 decor boxes, or when you have like 6 binders full of stuff for your house, do you think the situation is better trying to find something when you haven't labeled the things when they're in binders versus when they're in a pile? I tell you, I've looked through these binders so many times. A pile is such a great invention. Just put them on a pile, because if you have no way of structuring it, don't create 5 boxes called decor. The thing you're going to do is now you have to pull out all these 5 boxes every time you're trying to find something. Sorry, that was maybe too much. But the other part of the other property of components are these dependencies. So let's look at a couple of dependencies. We'll start in the top left. The main part of this picture is this paraglider jumping off a hill. And I will argue that the hill does not care about that at all. But the paraglider cares very much that he's standing on a hill and not trying to do this in a valley, because he wouldn't get very far. So there's a clear directed dependency of this paraglider on the hill. And when we look at the next one, you could say, oh, the girl, let's say that's her father, the girl is dependent on him to teach her or read her the book. But when I say daughter and I say father, then he's dependent on her being his daughter so he can be the father. So actually, they're dependent on each other for this relationship. The next picture is clearer again, the sun and the windmills, right? Sun, windmills, doesn't care too much. I've asked recently. Sun doesn't care. But windmills care a lot about the sun, so they can make air go one way really fast, and then you have wind, and then windmills turn. So again, a very direct dependency. Oops. And then the bottom right is again more similar to the picture above, which is all the cogs seem to turn with each other. And again, we have this, not a direct dependency, but some sort of cycle. And I think it's also interesting to note, you can probably come up with words to describe the things on the right, the main relationship, very quickly, whereas you won't find one on the left. Right? On the top, that's a family, and maybe at the bottom is a mechanism. I dare you to find a word on the left that kind of describes that particular relationship as quickly and succinctly. You don't. They're different things. They don't get described like that. So, sorry, I'll make it more software engineering. Let's draw boxes and arrows. So, if A depends on B, then B cannot depend on A. Right? And you can't cheat. So why are gems components? Well, for one, we have names, right? And we saw we had descriptive names like games and team, and you have used many gems that have descriptive names like that. So we have the labeled content, and we tend to use one gem that does a thing, right? So it's fairly unique. I know there's, like, sometimes we have multiple gems that do a similar thing, but it still holds very well. And we have explicit dependencies, right? In this case, we have gem A depending on B and C. I hope that's not me. And when we ask Bundler to compile or bundle this application, Bundler is like, yep, I know how to do this. This works perfectly fine. As soon as we change this just a little bit and create a dependency of this gem C on gem A, Bundler is also perfectly capable of telling us what's going on, but it will say, I can't do this. You have an infinite loop. I don't want this. Right? So we cannot have cyclic dependencies between gems. So they continue to be holding up to the properties of what components are. So, I apologize for I didn't realize the contrast was going to be like this, but I already said this was the most boring kind of cost analysis because everything was 2, and that's, if you can't read the red on the right, the costs for all of the ones we've looked at so far were 2, and we went over the benefits of method, class, namespace, module. So when we look at the cost of a component or the benefits of a component, we can't look at this file anymore because we know, well, we actually need to look at the packaging mechanism, right? We need to look at the gem as a whole. So there's obviously a couple ways to create a gem, and there's arguably a lot of variation in what minimal structure you create with that. I'm just going to go with creating a gem via the bundle command, and we'll analyze that. And I'll just to stay in that structure of the slides, let's look at the kind of obvious benefits of the contribution of a gem. Well, first thing is it allows for distribution. That's how we mostly get our gems. We get them from Ruby gems, and people have distributed packages of functionality. But the more subtle thing, and more important for the analysis of a component-based application, is that gems create a provably independent package of code. Provably independent, we have tests in there, we have all of the things that thing needs, including its dependencies, defined inside of a package. And that's actually way more powerful, so I'll go over more benefits in a second. But let's look at the costs. So when you generate a gem like this, you can output how many, I just checked the lines of code that get generated. I didn't put anything into this gem. It ends up being 88 lines of code. Now this number is high. You can reduce it dramatically. I think the minimum is about 15 lines of code because of the size of the gem spec that you need. But let's run with this number for now. It can be much lower. Again, I said gems work really well. I don't think this number is the problem. The problem comes when we try to package parts of Rails into our components. So we need to combine gems with engines. So now the command's slightly different, right? We don't no longer use bundle. We use Rails plugin new, and that's how we can create Rails engines or the things that use parts of Rails. The benefits of this are exactly the same as that for straight up gems, and that is they allow for distribution, right? If you've used Kaminari or ActiveAdmin, you're using gems that package engines to give you functionality. And it's the same. It's a provably independent package of code with Rails inside of it. And doing the cost analysis again, well, there's a lot of code that gets generated. There's 528 lines when you just run that command on whatever version of Rails I was running. I bet you that changes from time to time. But that's a lot of code. And most of this code you actually can't get rid of because there's one thing that gets put into the test folder, which is a dummy application, which is a full Rails application that for tests mounts the engine kind of inside of itself so that you can run tests against it. And you need that thing, otherwise, again, or you write untested code, and then you have other problems. So now the cost analysis of this table is slightly more interesting. And you can see the Rails components blow the costs of these other things out of the water. And I think this is one of the prime reasons why I've been, well, talking to a lot of folks over the last couple of years of doing this, but I get a lot of pushback also because they're saying this feels weird because it feels like we're misusing something and it feels like it's too expensive. It doesn't feel right. And I agree, this doesn't feel right. But why am I still doing it? I have not written a Rails application in years that basically didn't use this mechanism. I want to quickly go over why I still think we need to do it. So just to highlight a couple more benefits. With this structure, on a high level, without knowing how much is in each of these constituent parts, we can see what the app does. We see here that on the right side, there's an admin for Teams, and there's a Teams underneath. So we know it's got something to do with Teams. And there's games, and they're being admin. So we have two admin components here. But then we're making predictions. I don't know if for the game on Sunday or some other game, but it feels like we're predicting the outcome of games that teams play. That's all we can glean from this. It could be, we could have tens of classes in all of these, but we could still make this kind of abstract statement about the application just because we're seeing the high-level structure. The provable independence is super important when it comes to testing. Imagine we change code in predictor, here on the bottom left in orange, and we break it. Everything that depends on something that we build can break by us breaking the thing, right? So if we break predictor, we can break prediction UI and we can break the application. We cannot break any of the green parts, or said the other way around, when you change only predictor, you do not need to run the tests for any of the green parts. And the more you have this kind of structure, the more you can get away with just testing the things, and that they're now smaller, that you have, well, provably affected potentially. And creating new stuff is also pretty cool in this way. You want to create a new predictor, maybe based on some fancy machine learning. Well, you put it in a new gem, and you can easily see how you would swap in this new gem for tests at first into your application, and then only when you're ready, you kind of cut the cord to the other one, remove it from the app, but you've never polluted the existing code with your new code. You've kept it separate, you tested it independently, and you were able to swap it in. But all of this, I think, gets dwarfed by this aspect that I was trying to say so clearly at the very beginning, and that is the management of complexity. When, let's say you have a thing, a component, with 100 parts in it. The number of combinations where you can put these together into subgroups is this number, whatever that is. When you split these 100 into two buckets of 50, that's your number of combinations. When you split it further and further and I can say this number, 10,130. So the combinations that you can build with larger systems are growing exponentially, obviously. And I think that is a measure for complexity. Your bullshit meter should also be going off right now, because obviously we're never going to be quite that complex. But I want to point out that while these numbers are probably overstating the complexity we get with a growing code base, I'm not sure how much. And in fact, I think that the reason I've been using all of these techniques is because this cost has ultimately not scared me, because the benefits have been greater. I do want to mention that I've recently been working a lot in React, and this is, so here you have two React components, and now this is the React component, right? It's not a component in the sense that I was describing earlier. And this code, you can see component A depends on component B, and vice versa. We have a way to stop that recursion. If you call this React, it's totally fine. If you just do one thing and move these two components into two files, it still works, but React tells you, hey, you have a require cycle, right? And actually say, it's allowed, but you should probably refactor away from it. You can use linting to find this cycle and get rid of it. This gives you a component for JavaScript and for React. And what was the cost? Yeah, it's 2 again. So in comparison to React, this is slightly embarrassing that it's so expensive to create isolatable components inside of Rails. So I want to end with my call to action for you to make it better. For us to make it better. No, you got to work. The first thing echoes very much what Brian was saying at the beginning. If you don't participate in things like this, and if you don't share your stories, then I have a problem, because I keep running into folks who say, I've never heard of this, or that seems reasonable, and it seems like it will work for my application, but I don't find many resources about it. And I don't care if this is the solution for your app or something else is the solution for your app, but if you don't participate in events, and if you don't come up here, come up here or the equivalent thereof of publishing your things on blogs and talking at user groups, then it will just be obscure, and it will feel to everyone like they're struggling through this building of bigger applications alone, and you're not, right? You saw the room at the beginning. Everyone has this, or most of you have this problem. An obvious one, an obvious thing to improve. We must reduce the size, or the cost of Rails components. This dummy app is a huge problem. There have been attempts in the past to kind of get rid of it, but a little bit of convention over configuration should lead you to think, why can't I just use the Rails gems to run the tests, and I can just override whatever I need to override. It should be possible to not have that as a cost directly in your code base. It's code you need to manage. More broadly, there's a ton of tooling that one could improve. CI/CD I wrote here, but so for tests, like, you can make Travis work and it will like test all the components independently, but you have to do manual legwork. So again, it feels a little bit like you're paying extra to get this structure in your application. CD, like if you push an app like this to Heroku, by the way, there's no extra cost. Like Heroku doesn't even care that you have this kind of structure, because it's just a Rails app with a little bit of structure. But there's a lot of things we can do on tooling to make things better. There's quirky stuff. Like when you have so many components, right, and you have all these dependencies now listed everywhere in all these gem files or gem specs, right, you're suddenly depending on, and the app that I saw with the most components had about 60 or 70. And so if you imagine all of those are engines, which I'm not sure that they were, then you are stating like the Rails and its version 70 times. And while that's just a search and replace if you want to upgrade, and there's nifty things you can do with that, it also feels kind of clunky. So fixing dependency versioning across components is another thing you could work on. I think the coolest thing, and probably like the most advanced thing, would be, can we find ways to detect or extract components automatically? Like naively, take a class, take its test, separate it out, run the test. If it passes, it should be possible for that to be its own component. Most of the time, that's not going to work. Certainly not with active record models. Has many, has many, has many. They're just going to depend on each other. But the next level up would be analyze the classes and their dependencies as much as that's possible, with Ruby being a dynamic language, and see if there are any clusters of classes that if you separate them away, where you can see they're tightly coupled and there's only less connections to the outside. And can you use that to give a report to someone to realize that's how I should start looking at seams within the application, so I can split off code and make it separate. I think this will be super cool to work on. So structure, and the structure that that I want to add to applications doesn't make sense for small things. But I think we're all, or many of us are in big things, or they're aspiring to be. There's another aspect to that, which is if you don't learn to use the tools, then when you get into the situation, it's kind of already too late. But that's okay also. If you're in the good situation of having the problem, well, you're in a good situation. Your startup is still there, your code base is still relevant. So you might need to take the time to do a big refactor like this. And the longest one I participated in was about 1.5 years or 2 years transitioning from a monolith via a structured application using components to introducing microservices. And I know that there are projects where that takes longer, but it takes time, and that's okay. I heard that, or read that this particular highway, interstate, or NOT, or whatever you call that, took 8 years to build. But think about the structures that you're putting in place so that you can support cities as big as you can dream up. That's all I have. Thank you very much.